Let's move on to the next question after this. The 20th question says, if sum of the perpendicular distances of a variable point P, x, y from the lines this and this is always 10, show that P must move on a line. Okay, let's take a look at this question. Sum of perpendicular distance of a variable point P from the lines this and this. So these two lines are not parallel. This is one line, there is another line, and this is x plus y minus 5 is equal to 0. This is 3x minus 2y plus 7 equals 0, and there is a point P. Yes, x comma y, and you are talking about this distance and you are talking about this distance. Let's call this d1, let's call this d2, and the condition is sum of the perpendicular distances d1 plus d2 is said to be 10. Okay, d1 plus d2 is said to be 10. Show that P must move on a line. Okay, so you have to find the relation between x and y, and as the person is saying, that relation will be a linear relation between x and y. Therefore, you can say that P will move on a straight line, right? Okay. In other words, this is basically a question based on locus. Yes. Now, what is locus? Now, for those of you who have studied for competitive exams, you would realize that this is a direct question based on locus. Otherwise, you're not supposed to worry about anything. Simply focus on the solution, because locus is nothing for that matter, right? So let's see, d1 plus d2 equal to 10. How will we apply this condition? So for applying this condition, what do we have? We can directly write the distance of this point from this and distance from this point from this, and we can substitute it over here. d1 for that matter is modulus of, substitute this over here, this becomes x plus y minus 5 upon square root of 1 square plus 1 square, which is this. d2 again is equal to modulus of 3x minus 2y plus 7 upon under root of 3 square 2 square, which is under root of 13 modulus. This is what I get. These are d1 and d2 respectively. Sum of perpendicular distance of variable point from the lines this and this is always 10. So d1 plus d2 is given to be 10, and we are supposed to find a relation between x and y after this. So let's write this d1 and d2 in this particular expression and see where does that take us. So what do I get? X plus y minus 5 upon, I have a root 2 in the denominator, yes, and I can write a modulus on this only for that matter, plus d2, d2 is 3x minus 2y plus 7 upon root 13, and you have a modulus which is equal to 10. Now observe this expression carefully. Now modulus, what does it does? What does modulus do? Modulus actually gives a plus or minus sign to this, or gives a plus or minus sign to this, right? Does it create some squares or something? No, it does not create any squares or something. So you have a linear expression in terms of x and y, linear expression in terms of x and y. You will add those terms and you will get a linear expression in terms of x and y. Will you? Yes. You will simply get a linear expression in terms of x and y if you remove the modulus as well, right? At max, you will have 4 cases, right? One of the cases will be this opens with a plus sign, this opens with a plus sign. Another case could be this opens with a plus sign, this opens with a minus sign. Another case could be this opens with a minus, this opens with a plus, and the fourth case can be this opens with a minus, this opens with a minus sign. The fourth modulus can open in this way. The two modulus can open in these particular ways, and it actually depends on the location of P with respect to these two lines. P lies in this quadrant, this particular region, this particular region, or this particular region, or this particular region. That is dependent on the location of P. Now we are not concerned with the location of P over here, but these are 4 cases and they are actually based on that idea. Okay. But each of these cases, do you realize that in each of these cases, what is happening is you will get a linear relation in x and y. In this case also, you will get a linear relation. Basically, x and y will not be raised to any powers, and you will get basically x and y in addition only, right? X and y are not coming in the denominators, you will not get any powers, you will get x power 1, y power 1, and along with them, you will get some coefficient of x and y, which will be complicated. You can see this will be root 13x, 3 root 2x or something of that sort, right? So you will get root 13 plus 3 root 2 or minus 3 root 2, something of that sort. So in all of these cases, you will get linear relation in x and y, and yes, that is the only important thing that you need to observe. You can solve all of these 4 cases, or you can solve any one, and then on the basis of that you can comment that P lies on a straight line. That's the complete proof of this. What? Oh, you haven't solved any of these? No, I haven't solved any of these. You can solve any of these, or you can solve all of these on your own. First cross multiply this root 3, root 2, and this will become 10 root 26 over here on the right hand side, and take the plus plus signs, then take the plus minus sign, then take minus plus sign, and take the minus minus signs, and in each of these cases you will get a linear relation between x and y that will be equation of a straight line in each of these cases. So point P lies on a straight line. Yes, that's a complete proof for this particular question. I'm not solving it any further. I'm not solving the cases any further. Right? You can do that on your own. That's pretty simple. Right, that's the complete solution of this 20th question.